Hello, everybody. Welcome to another installment of Mankind in Training. I am your host, Joshua Parr. I have today for you a presentation, and I will show you a few things. One about binary trees, and another I will share with you will be about a neural network and its setup. So this here is a binary tree with some values that you'd see in like a tensor maybe. So here is the origin, the root node, the very beginning, and then to its left, it has a child. This child is less than the root, and then on the right side, it will be more than the root. And then for it to be a full binary tree, it needs to look just like this. It needs, well, mine's a little wonky, but it needs to be like this. It needs to be complete. The bottom row doesn't necessarily have to have children, but if it does, it needs to have all the children. It can't have just one node that's bare. So I'm calling this node child A, this node child B, and then this node would be C, D, E, and then this is child node F, child slash parent node F, and then so on and so forth. G, H, I, J, K, L, M, and N. Now, when they ask you what the depth of a tree is, its origin is 0 depth, and then the first rack is 1, and that's why I drew these lines to denote depth, 1 and 2 and 3, but also maybe to think about we could make a sort of data set that is a tree, but where it's like a graph. And then these are actually vertices, and these lines are edges. And we could add lines like this at the depths and make a tensor tree. But so down here I have some laws about sets. So you have a set of numbers A and a set of numbers Q. We could say that A is a member of Q, meaning all the elements in A are elements in Q. Q may have more elements, but this says A is not an element of Q. This says that A is in Q, same as this kind of. It's included in Q. And then this says that Q is a superset of A and A is a subset of Q. This says the union of A and Q. Think of two circles and in the middle they met. And this is everything all filled out because it's the union of both the circle A and the circle Q. Contain all of those elements as a visual. And then this is the intersection of A and Q. Say these two circles here, but these elements are different. But these elements is what we're looking for. The intersection of A and Q is where there's like elements in both circles. So nextly, we are going to hop over to a picture of a simple neural network feed-forward type node system where we have nodes A, B, and C as origin starting points. And then they are sent on to weights 0 and 1. And then weights 0 and 1 make a decision and send it on one of the edges with a different weight. Say these lines will all have values too. I just didn't want to go through and write all of them. and then these will be fed forward to these weight nodes. It'll get that value at the edge, and at the vertices, it will be the new value, and it will decide where it's going to go after that, which weight system to go with, and then it will be sent to opposite foci at the very end before the decision. And that is a little bit of something how this is a very small version of a neural network. A lot of them have thousands of elements, so this is very small scale, but it's a very simple version of what's going on there. So quickly, I think I'm going to hop into this real quickly. This was the laws I was just indicating here, and I'm going to go to right here. Yes, these are laws that need to be followed regarding sets and set theoretic equalities. So this is the idempotent laws, which meaning the union of x and x equals x, and the intersection of x and x equals x. The commutative laws, the union of x and y equals the union of y and x. The intersection of x and y equals the intersection of y and x. The associative laws, where the union of x and y and the union of z is equal to the union of x and the union of y and z, and the intersection of x and y and the intersection of z is equal to the intersection of x and the intersection of y and z. And the distributive laws are the union of x and y and z's intersection equals the union of x and y and the intersection of the union of x and z. So then x time the x union of the x intersection of the union of y and z is equal to the x and y intersection of the union of x and z's intersection. The identity laws, the x's union with a null set is x, x's union with u equals u, x's union with a null set equals null set, x's union with u equals x, or x's intersection with u equals x. Oh, sorry, I probably said that backwards on the last one too. Complement laws. The union of x and x prime equals u. X prime's prime equals x. The union or the intersection of x and x prime equals a null set. X minus y equals x is intersection with y prime. De Morgan's laws, the union of x and y prime is equivalent to the intersection of x prime and y prime. The intersection of xy prime is equal to the union of x prime and y prime. The consistency principle, if so x is included in y if and only if the union of x and y is equal to y, and x is included in y if and only if the intersection of x and y is equal to x. So that's what I wanted to get after today for you, and thank you for watching. I know I'm not been on here frequently enough, but I'm gonna keep going, and I'm gonna keep giving you guys explanations of things and videos and math, and I'm gonna try to do more coding because that's what I promised initially, but I wanted to explain some basic things and then some more complicated things that I was working on. So thank you guys for watching. If you like, subscribe, and I will see you in the next video. Bye. Thank you. Thank you. Please come again.